we finished with the first level analysis and stuff like that. Let's see what we want to know, what we want to do now, right? Is to do Functionnectome. So Michel explained already what we are doing. So we have this time series we got now because we did the first level analysis. So we have different time series for different voxels, and what we want to do is to project this signal in the Y matter. And it's a way of, so these voxels are, all these voxels are based on the Y matter using priors, are connected. So we weight the signal from these three voxels to, not doing a mean, but weighted the signal from these three voxels to get the signal, to get the new signal from the white matter in this location. But we shall already make the explanation of it, but just to, so there is a command line we will use here. It's on the GitHub again. So if we go there, so let's take the first command. You do that, so yes. Okay, so let's close everything. Let's get rid of everything. Okay, let's open a new shell this time. So we'll install Functionnectome on the Nordesk container. And I open a new. Is it working? Let's close it. FSL. Bye bye. So I want a new shell. Yes, new shell. Oh, let's go to zoom in. Zoom in. Zoom in. Zoom in. Is it big enough? So you take the first command line in the GitHub. So if I go back to the GitHub, okay, so that we forget about spatial normalization, so we don't care. So that is pip install that. So you copy, you go to the Nordesk, your new shell, you do paste as you can. And normally at the end, you have successfully installed Functionnectome. So yes, what I was saying that the last time we didn't finish completely. It was a long session, intense session with a lot of issues. So as we have more time today, so I wanted to just to finish with a Functionnectome and to, so there is different options I have forgotten to tell you. It's why it was very long. So let's, so if you like, and if you have enough stamina left, so you can open back your Nordesk app, either the local version with Docker or through the Nordesk Play on the cloud. And let's start again. Okay, so that I put that here. So it should open soon. Okay. So we were at the point, so let's open Functionnectome. So through the GUI. So if you install it, normally you should just have to do that. So I don't. So if you go back to my GitHub tutorial, let's see where is it. Okay. So there is, so if you don't have it installed, so just to remind the command line, so you go to, so there is two lines to run. So the first one is the pip install. So let's put that. Okay. So up. Yes. And this is the last command in the. Let me put. Yeah. Okay. So that this command is installing Functionnectome. So you can install it with the pip install and the command you see. And after, normally, you can type Functionnectome GUI. Yeah, like that. So that you can. Okay. And it should open the Functionnectome GUI. Yeah. That looks like that. I have everything. I am the master. No. I know I don't have this one. So you remember, okay, so this is the Functionnectome. So what you need for this GUI, for doing the Functionnectome, you need your board data set, okay? So your board image, your 4D with the time series. So either you select one board file from one folder, so this is what we are doing, or if you want to do more than one, you can use this part to do kind of automatic or to do a serial reprocessing of your data, okay? So that you select the board, which should be in the standard space. So we discussed a lot about it. Everything should be in the standard space, okay? So this one, you can find it if you remember with FSL, so if you go to the folder, the feed folder from FSL, you need to remember, what is it? There is a reg that stands for registration. And inside, you have all the images that have been registered. So the one you need to select is the example func to standard, which is this one, okay? So for the purpose of the tutorial, so I didn't select the 4D, the time series, the bold time series, because it would take a lot of time. So this one is just a 3D image. So just one API, just one bold image, but it's enough for the, if you have time, you can, so I put the command lines, you can register your 4D image and to use it to do the real Functionnectome image. Everybody's is okay with that? So you yes.
So
yeah.
If I work with fMRI data, I would take the MNI space that's reprocess.
Yes.
All time series.
Yes, the all time. So Functionnectome, as we discussed and Michel discussed it takes the 4D to project the structure, the functional to the white matter. It needs the time series to really adjust what are the voxels that are connected functionally and to the white matter. So one, and you will see it will give you a warning if it is only one image because it's not, you cannot, it does it, but it will not do it properly. Okay. So normally, so this part is to choose what you want to do, either a voxel wise functionnectome, so it will do project on the white matter voxel by voxel, or you can do also a region wise functionnectome, so it will average the functional data to white matter area. So this part was yeah, it's when I started to my mind was not properly working at the time. So you need to select a gray matter image, which is in the standard space too. So normally, if you did the last time, but I can show you again. So you go there and you select one file. And this file should be also in the right folder. And so after the segmentation, so if people didn't do it, I can show it. So everybody has a segmented. So the image to segment is a high resolution to standard. So this is the T1 image we segmented with fast. And it creates 3 images, SIG0, SIG1, and SIG2. Yes, and you select the SIG1. High res to standard SIG1. Okay, everybody's fine with that?
Yeah. It's in the SEG1.
SEG1, yes. So sorry, I can show you again. Let me.
T1W brain SEG1.
No, it's in the reg folder. So if you go, let me show you again. Yes. Yeah, let me show you. So you go to your feed. Yeah, the fast. So, but I can show you. Okay. So it's fast. So you go to FSL again. Yeah. Yeah, I know. So it opened that. And instead of writing FSL, you can directly, with a capital F, you type fast. And it should open only the fast model. Okay? So.
Oh, yes.
You have it? You have
the platform, yeah.
Okay.
Yesterday I couldn't do it because
Okay.
Excel was too slow.
Okay, so should yeah, mine is slow today also, so let's wait a little bit. So in the fast, it's pretty easy. You select the T1 image you want to segment, and the T1 you want to segment will be high res to standard, which is inside the feed folder. Yeah, it's here. Okay. So when you have the fast here, you go here. You select the T1 image. So the T1 is inside the feed folder, reg folder, and you select the high resolution to standard. Yes. Yeah. Yeah, it's a gray matter mask. So yeah, it limits the signal from the board only to the gray matter. Yeah, just to limit. Yeah, yeah. It doesn't want to take all the signal from the board image, just the gray matter. Yeah. So the idea to repeat is so it will project all the bold to the white matter using only the ones that are in the gray matter mask. Okay. So you select the high res, okay, and you press also output one image per class. Per class. You need to click to tick this this button, okay. And when it's done, wait, yes, you just need to do that, and you press go. So you fill this one, and you click go. So I already did it, so I will not do it. And so here you select. So I'm going to redo it just so when it's done, you go here. It's same mask for. Why it's a mask for? Yeah. And you go in the right folder, and you should see different images. So here you will see better. It's in reg. ls. Okay, so in the reg folder now, after you did the fast, you should see 3 images, which is PV0, PV1. So that is the probability of each class, and you have masks which are called seg0, seg1, and seg2. And the one you need to select is a seg_1. Okay. So something else we can do during the time for the people who are running the fast software, we can do something. So one option I was forgetting is the number of parallel processes. If you have a big computer, or if you have more than one CPU, you can increase the speed by increasing this number. So the thing is, how many CPU you have on your computer? It's a good question, because sometimes you don't know. So in a terminal, what you can do, so you know ls, you can do ls CPU. But if you do that, it will give you all the CPU you have in your computer. So for example, here, if I go up, yes. So it gives me eight CPU. So you can see the number of CPU you can use. So you can take this number and put it here. Okay. So when you type ls CPU, it will give you the architecture, the type of CPU, the other size, and there is here CPU, the number of CPU. Mine is 8. So for you, it will be not 8, it will be something else, but you can use the number it gives you. Output folder, it can be everywhere. So let's call it here. So what? Shoot the mask. Let's open. Okay. So you put the number of things you want to what? Masking option. Let's close it. So be careful. Sometimes you have a window behind the other window. Okay. So here you change the number of parallel processes. You need to select the prior. So if you reinstalled Functionnectome, it will not find it. So you need to do, for example, yesterday we download the prior. So you can select. So you go to. So I am redoing it. So you go to this first. You click on this one and you do select. And you need to find the one you downloaded yesterday. So where? Up. Mine was here. So it will be called priors full proba 3T comp 9, and it should be somewhere in your home directory or where. Yeah, you need to remember where you put it yesterday. Okay, you select it. So I'm not doing it because okay, right. And the last thing is the output folder. You can call it as you want. If you don't put the path, so the directory, will put that in your home directory, or I think where you launch when you run the Functionnectome. But yeah, you can call it Functionnectome. Okay. And you tap, and when that is done, so there is other options, but we don't care about those options. And you can launch it. And this time it should be faster because you increase the number of CPU. So if you have 16 CPU, it will be 2 minutes. So when it's finished, and it should be, for some of you, so you need to go to your Functionnectome folder, and you should see, what is it? Yeah, you should see a voxel-wise analysis folder, and within, you will see an image. And again, that will be in the same format as the original file. So it will be a 4D. In our case, it's only one volume, but it should be a 4D image of your board scan. Okay, so there is different folders, but if you go inside, at the end, there is an image. And you should see something like that.
What's 1068? What's the critical?
That it should be, so this is for this image. So this is, so for example, for this point, he computed a value from the cortical value. So it's just, so again, Functionnectome is just projecting the values of a time series, or in our case, only one value, from the cortex to the white matter. Okay. So it should be comparable to what, if you see if you look at your board image, it should be something similar. So, yeah. Yeah. Yeah, you can mask it. Yeah, I'm trying to. Finally, there is not a lot of things to see. Just it's a strange image because it's a board image. Normally, you should see signal only the signal is higher in the cortex, but in this image, the highest signal is in the white matter because you projected everything in the white matter based on the priors you enter during the process.
No. And so, what's the value of the box?
It's a bold. It's bold. Yeah. So yeah, the question is what do you do with that?
Yeah.
So the thing is, it's like if you had bold image. So after you go to fit and you do your statistics.
And I can do my statistics like for a bold signal.
Yeah. And so what you will see, the contrast will give you, for example, congruent versus or incongruent versus congruent. You will see cluster of the difference within the white matter and not anymore in the gray matter.
But we still get like voxel values for the gray matter.
Yes.
It's really small. Or like we put the gray matter mask.
That is only to extract the values
of the white matter, but the 55 now.
Yeah.
It has values for the gray matter.
Yeah, you don't. Yeah. So we were discussing that. It's why if you look at the size of the image, it will be much larger because it adds the signal from the gray matter to the white matter. So you have both
Okay.
Also, yeah, it's,
Okay.
And so then I would perform my statistics in SPM FSL
yeah,
with contrast.
yeah, and you do a mass.
And I get my Functionnectome.
So if you are, so in this case, it's a task-based ephemeral protocol, but if it is resting, you can do connectivity
Directly here, yeah.
Ah, yeah, the API signal. The API artifact where you have system flexibility artifact.
It works exactly, but
Yeah.
this area doesn't show up in the
Yeah.
studies. So do you have any idea?
So you should see your the people who are doing the scan. You can do the phase encoding. So you I will not go into that, but when you record your image, you can do phase encoding in different directions. And so based on this direction, so for example, if you do phase encoding, always wrong, but if you do left, right, you will get an artifact going from the anterior posterior. Okay? So like that, you can avoid artifacts in the temporal region. So you need to change the phase encoding, because if you do the phase encoding in the other direction, the artifact will be in the temporal region. So you will do something like that, and kind of remove the signal or gives artifacts in the temporal region. So you need to change the direction. If you are really interested in the temporal region, you need to change the frequency to get something which is not, maybe I can show you. I don't know if it is corrected. Let me show you.
Never shows up on the things or
Yeah, because it's a standard to use the phase encoding, because people are not always interested in the temporal. So if you go here, you go in the data set, let's look at this one, Func. Let's take the first one. Okay. So here, in fact, okay. So in this one, they did the phase encoding. So if you see, it's not very clear, but you look at the frontal. Why I have something? Yes, can I? Let's. It's just in. Okay. So you see, this is the frontal part, and you see there is a bump here, which should not be. There is no people with a bump of. And so that is the classical susceptibility artifact you get in API sequence. This is the API sequence is a ecoplanar imaging you use for to get bold image. And as the phase encoding, so I don't remember, the phase encoding is maybe based on the phase encoding, you will get an artifact here. So if you do the phase encoding like that, you will get an artifact in the temporal regions, because it's very sensitive where there is a very brief, a fast change of tissue, for example, air. So it's always in the sinus where there is bones air, and there is a signal that is lost. But as you can see, if there is here, you should see if the phase encoding was like that, all the temporal region would have been a little bit shift on the left or in the right. You good? So that's it. You have your Functionnectome. So if you want to redo it on a 4D, it will take more time. So you need a big computer to do it. But